Okay, so everyone, today we will implement the RS flip-flop here. So you can see the block diagram first. This is our RS flip-flop. We having S, we having R and the clock pulse here. Okay, and this whole system is RS flip-flop. We have two output Q and Q dash. Okay, so during the high clock pulse, see there are few conditions I'm telling to you before implementing this. See, when the value of clock pulse is 0, no matter what are the value of S and R, we always get the memory out here. Okay, but when your clock pulse is high, when S is 0, R is 0, the output you can see from here. Okay, for high clock pulse, what we got, 0 0, we got memory. Okay, output we got memory. Clock pulse is high for R0 S1. Okay, this is output. Q is 1, that is steady state. And when your clock pulse is high and R is 1, S is 0, we get reset. Okay, and 1 1 is illegal state. Basically, it's not allowed here. We're not able to recognize the output out there. So this is the truth table and this is the next state. Let's say S is 0, R is 0. The Q value, the memory is 0. So we got Q plus 1 is also 0. When S 0, R 0, Q is 1. When Q plus 1 is also 1. So that means Q n plus 1 is following Q. Okay. Q n plus 1 is, you can see, following Q. And when S is 0, R is 1, the next stage is always 0, no matter what is the present state. And when S is 1, R is 0, and when I give the new clock pulse, the new state is always 1. This is set state. Okay, so I hope you understood and see the block diagram and as well as the circuit diagram out here. So go to the multisim, you can easily download this. So in this multisim, you can see this value is S, this lower value is R, and this is used for clock pulse. So initially I'm giving 0 clock pulse and this is the initial state. You can easily recognize this is the initial state. Okay, and this whole circuit is implementation of RS flip-flop. Okay, so I stimulated here. Now the clock pulse is 0. So whatever is the input, you can change the input. You will not find any change in the output because this is the memory state. So in the memory, the store is 0 1. So Q is 0, Q dash is 1. So we always getting 0 1. Okay, no matter what is our input. Now let's say I change the input. So again I'm changing the input. Okay, so clock pulse, sorry. So when I change the clock pulse to 1, both the inputs are 0. So again you see we getting memory. Okay, the same value we getting. This is 0, this is 1, so we getting 0 1. Okay, I will change it also later on. Now I will change S become 1, R become 0. So when S becomes 0, you get Q is equal to 1, Q bar is 0. And when I made it 0 1, S is 0, R is 1, you get 0 1 as your output. See, this is 0 and this is your 1. Okay, now both the value are 1. So both these props, these LEDs are blink here. So this is an invalid state. Okay, because we not recognize that. Now again see, I'm changing the clock pulse. You can see this and check. The clock pulse is 0. If I change the input, okay, let's say I'm setting the input like this. Okay, like this now. Okay, and now my clock pulse is 0. As soon as my clock pulse is 0, the output remains same now. Okay, if I change it 1 1, no matter, 0 1, no matter. So it's a previous state, it's a memory. So clock pulse is absent, we always get memory. And when clock pulse is 1 and both these two also, see, clock pulse is 1 and both the value are 0, we got memory 1 0. But as soon as we change it 1 0, we get Q1, Q bar 0. And I change it to the 0 1, we get 0 1 out here. That means Q becomes 0 and 1 1 is invalid state. Okay, I hope you understood till here now. Now come to the excitation state. Okay, so let's say my input is this. So I change it. Okay, so I give another clock, so it remains same. So that you can see out here also the next state. Okay, when S is 0, R is 1, we always get 0. Okay, we always get 0. See, you can see S is 0. Okay, S is 0, R is 1. Okay, we always get 0 1. Next state is always 0. Qn plus 1, here you can see 0. Okay, and now if if you change this, okay, if you change it 1 0 1 0, your next state is also 1 0. I'm giving a clock pulse out there. You can give the clock pulse. Okay, no change out there. So that means when S is 1, R is 0, we get the next stage also 1 0. See, S is 1, R is 0. So Qn plus 1 is 1, no matter what is the value of present state. So if I give the new pulse, it remains same. Okay. So this is the complete implementation of your RS flip-flop. So how to made it? See, these three, how I choose these three value, I will let you know from the beginning. So just stop the stimulation, then delete it. So go to the that part, okay, place value, then component. In the component, search for NAND gate. Okay, so you can see two NAND gate out here. So copy it. Okay, how many type we require? 4. So we require 4 NAND gate out here. You can see the 4 NAND gate I just implemented. Then you require some props. Okay, prop for output. So any color prop you can choose out here. Okay, let's say we require this, and we require one more. Okay, now we require digital. Okay, uh, this value just okay. So for choosing switch, digital constant, I think. Okay, or digital pull down, no, switch, digital switch, no, just give me some time, I will remember the name. It's a digital stimulator, constant, digital constant I will choose. Let's say it is changing. No, it's not changing. So we require some switch who give the value 0 1. So just give me a second, I will search. Okay, just give me a second. The switch name is, okay, I will just searching, and then I will draw it. Because you need to remember the name, otherwise it's difficult to search them. Okay, and the name is, see, either I can choose a slip over switch, but I doesn't want to do it by the that flip switch. It's little bit difficult, so I choosing this one. Just okay, the name is, you can search from here, interactive, interactive digital constant. This is the switch. Okay, so copy it 3 times for clock. Okay, you can choose the clock also here. If you are not using this, you can use the clock current also, clock pulse. Okay, digital constant, this, see, digital clock, you can choose digital clock also here, if you require. If you're not using this, okay, then what we choose the digital clock out there directly. See, okay, and now you connect this to here and connect this, both the inputs, 0 1. Okay, these are the values 0 1 we got here. Then connect them, okay, from here and here, and then the input should be common. Not this, like this, just wait a minute. And then the output of this is connected here, and the output of this is connected here, and this is connected to the probe with the values here, and the output is connected with this probe here. Okay, now stimulate that one. Okay, you can see the digital clock pulse is given here, the frequency is also given here. Okay, the delay time is also given. What is the frequency? I can choose 3, let's say. Okay, so such that it is more visible, I can choose the clock values. Let's say it is 10. Okay, the frequency I have choose 10. You can now stimulate it. So you can see here. Okay, frequency all of know. As soon as you change the input, your input S is 1, R is 0, you get 0. Okay, you get 0. And now if you change it to 0 1, okay, to 0 1, you get 0 1. Okay, Q becomes 0 and this become 1. And similarly you get the next state. Or either if you're not able to understand with the help of this clock pulse, just remove this, okay, this clock. Just stop this stimulation, remove this clock now, and copy this again. Just copy here. Okay, now connect this to both the pulses. Okay, now give it a 0. Okay, this is the initial state you're getting. So if it is 0, the initial state not changing, it has always remain same. This is memory. And as soon as it become 1 and it becomes 0, both become 0, you get again memory, no changes here. But as soon as it is 1 0, okay, now just stop. See, 1 0 1, we get 1 0 out here, and this is 0, this is 1, we get 0 1. But as soon as it becomes 0, it always give you the memory, it will not change. See, it is not changing whatever the value you giving. Or similarly, if it is 1, it is 0, again it is memory, whatever is the memory, it will remain same. It is 0, it remaining same. Okay, so this is your RS flip flop, you can easily stimulate. So please remember all this. Okay, with the help of this you can verify that. Okay, now you can save it. I just save it as a project out here.